Over to you, Matt.
Everyone, thanks for joining us this evening for my talk here about functioning within an Azure Serverless framework. My name is Matt Will. I'm a principal software engineer at Springtails, and I'm our engineering COE lead. So I've been working at Springtails for the last 3 years, and I work primarily on our channels group. So as Alex was kind of describing a little bit, all the different marketplaces that we work with for selling our products, and then receiving those orders and things like that. Our team is responsible for communicating all of the catalog data to those various marketplaces to represent what we want to sell on each of those platforms, and then we retrieve all of the order data to and import that into our systems to start the order fulfillment process. Prior to Spreetel, I worked at Don't Panic Labs as a code wrangler and software architect. In my time there, I spent a lot of time building out greenfield solutions that ran on a variety of platforms. We tended to lean towards recommending Azure, but we would build out solutions for AWS or in-house as well, based upon whatever the customer was needing. And when we started with our Azure, we really treated it as infrastructure as a service, primarily using virtual machines and things like that. And as time went by, we started to implement more of the platform as a server, or platform as a service, and serverless solutions. So, and my very first professional experience was as a software engineer at Fiserv, where I worked for 9 years as on the business and corporate internet banking products. When I started at Fiserv, really the closest thing to a cloud that we had was making sure that our software ran with data centers that Fiserv had, and those data centers had dedicated hardware and load balancers, SSL accelerators, all those kinds of things. And it's just really interesting to see how far we've come from those things and where we're at now today with the cloud. So one of my former coworkers at Don't Panic Labs, he always had this sticker on his laptop that said, there is no cloud, it's just someone else's computer, which basically means, as we're all aware, that the computer belongs to really one of a handful of other companies. So then, the question that comes to mind is, how can we use someone else's computer if we aren't using servers? And so really, that the question is, what is serverless computing? And serverless computing, oh, my slide's not showing up the right information here, so apologize for those bullet points not working, but serverless computing is actually a framework and set of technologies assembled together by cloud providers to make running software faster and easier to do. More times than not, these frameworks tie you to a cloud provider making that framework and assembling that, but that's starting to change a bit with the usage of containerization technologies and also shared runtimes. And serverless computing just really means that you don't have to manage large fleets of virtual machines, the resources dedicated to those virtual machines, and updating server software, patching individual applications, or managing security on those servers. As an example, I've never run into an instance on a serverless app where it's crashed because the server ran out of disk space, but I've had plenty of servers, whether they were virtual or physical, run into those kinds of problems in the past. And I'm sure also that IT and security teams have to love that there are fewer servers that they have to keep track of in their inventory of machines, and making sure that they're fully patched and protected from malware, using all the latest updates and everything like that. Because much of serverless computing is starting to really center around the processing events, it makes it a lot easier to scale out to handle more events all at the same time. One example of this at Spreetail would be processing orders coming in from a marketplace. We currently pull the marketplace for all of the new orders that come in every 5 or 10 minutes. And from this response, we process those orders sequentially. If we don't have that many orders, it's not really that big of a deal that we're processing them sequentially. But when we have times where we get a large rush of orders coming in, like, let's say on Black Friday or Cyber Monday, where, in those 5 minutes or 10 minutes, we could have several hundred orders come in. processing them sequentially can really be a big drag on our processing times. Even if each order only takes us 1 second to process, or a second or two, that means that we're going to spend 2 to 3 minutes running. And Vayab, you've got a question?
Yes, I wanted to suggest if the bullet points are not showing up correctly in the full presentation mode, you might try coming out of that. That
Yeah,
might show.
I think
It's
it was
coming
just
now.
it was just that one slide that's bad. So,
Okay. No.
yeah.
Sorry to interrupt. That's what I
Yep.
just wanted to
Yeah.
suggest.
Yep. No worries. So, but yeah, with the processing of those orders, it's not going to be too bad if we were able to scale out that massively for that short period of time to process and run, through those couple hundred orders. So serverless applications are generally built out based upon the amount of computing resources that they're consuming rather than server uptime, which is, the metric that is usually used when we think about running virtual machines. So, the way of thinking of it is kind of thinking about the difference between owning a vacation property versus a timeshare, the vacation property where you can only use it maybe a couple of times a year, and if it sits empty the rest of the year, that's kind of a lot of wasted time. Whereas that timeshare, could be more affordable because you're really only paying for the time that you're using that property. And so, why would we want to use serverless computing? I'm hoping that you all have picked up on a few of the reasons that I've alluded to already. One of the biggest advantages is paying only for the resources as you use them, which could translate into substantial cost savings. An example of this right now is at Springtails, we have a webhook API that we expose for Facebook to request any of that product data that we're using. Facebook's systems request this data from us once an hour, and it usually takes us, somewhere around 2 to 3 seconds to process that request. Because we have this deployed just as a traditional ASP.NET Core web service, that means it sits idle on our Kubernetes server for 59 minutes and 58 seconds each hour, or it's basically idle 99.9% of the time. Another reason is it makes it a lot easier to build event-driven processes. So, we think about most of the things that are occurring in our world. It's, we're always responding to events. And so for Springtails, what this means is that as our marketplaces that we work with are slowly starting to adapt to using webhooks, we can tie into those webhooks and receive notifications of events. So instead of us asking every 5 minutes for, their batch of 100 orders, they will immediately tell us when there is an order. And they're also putting into place with those webhooks, retry logic and everything on their end. So, it makes it just a lot easier of a process to handle. And so if most of our systems are already designed to be event driven, it will make the addition of new marketplaces easier. It will also make it easier to add on new features as marketplaces make enhancements to the services they provide. One of the other things is really massive scaling. So, processing a large number of events all at the same time. I'm an avid runner, so one of the examples that comes to mind for me is the start of a race and all of the people who use their watches with Strava to track their running. And so when they start their run, if they've got the live tracking feature turned on, it will send out text messages and emails to whoever their emergency contacts are. So, when a big race starts, so like you've got your Boston Marathon, New York City Marathon, something like that, and a lot of people are tracking their run, that means that there are a lot of different emails and text messages that have to be sent out, but that only happens for a very short amount of time. So being able to do serverless processing with this means that they don't have to pre-provision all of the servers or all of the scale that they need to be able to handle that. They can rather just let the serverless frameworks scale up and send all the messages that they need to, and then scale down as they become idle. So That just really makes it a lot easier for everybody involved, whether it's the IT DevOps team or the engineers that are involved in doing support and things like that. Because the goal of serverless computing is to write purpose-specific code, it means that we can more easily distribute load across multiple systems. Or realistically, we really let the cloud provider handle the distribution of that load rather than having to run multiple copies of a single process or, on a single server or set of, constrained resources. So that would be kind of like if you have something running in Kubernetes on your Kubernetes cluster and scaling it up to 10 copies while you still have a restricted set of resources that are available to you, as opposed to if you're running this fully native in the cloud, then you can distribute that load across as many servers as the cloud provider is really willing to let you use. And finally, the deployment of microservices based on serverless technologies becomes a lot easier. Since the services and components can be purposely built and quickly deployed, companies like Facebook, Amazon, Apple, Netflix, and Google have daily deployment counts in the thousands of times per day. Now, I'm not suggesting that we all need to go out and deploy our systems hundreds of times a day, but even being able to, have a setup where you can deploy multiple times a day makes it easier, because you can deploy, validate it quickly, do things like blue-green deployments, and once things are validated, switch all the traffic over to the new version. And so then that really should help take off a lot of the anxiety and coordination of effort that goes off with around everyone having to sign off on a release. Back when I started at Fiserv, I was talking about the data centers we had. One of the other things that we did is we had an annual release cycle. So that meant that, for 11 months out of the year, everybody's doing all of this work kind of in a vacuum. And then at the very end of the cycle where we were going to cut the release, then everybody was just trying to make sure that everything was tested and perfect, because it meant you wouldn't have many chances to get out and fix any problems, fix any issues until possibly a year later. But now that we're at the point where we can do multiple deployments in a single day, we can get out those bug fixes really quickly. So next up, we want to talk about who offers serverless. And I'm going to pause for just a second. I think what happened was, I think the font got changed on my my white screens here. So let me see if I can try and fix this real quick. And are you guys all still seeing my window right now, or is it okay?
No, we are not seeing your window right now.
Okay. I'll just share in the standard window here for these screens that are in the with the white background, because it's not sure what happened exactly, but here we go. So who offers serverless frameworks today? So first off is Amazon and Azure, and they have support for a wide variety of languages that they support today. So most of those frameworks that they're supporting are going to be either C#, JavaScript, TypeScript, Python, Node. I think Azure also maybe supports Go as well. And so with the support of these wide variety of programming languages, it's really easy to, work with whatever frameworks you're currently using to build your applications today. And because of the wide adoption of both Amazon and Azure, you can find a lot of really good documentation out there, as well as a lot of good examples, both on the Amazon and Azure side of things, as well as from answers like through Stack Overflow, blog posts on Medium, and everything like that. The next two providers after that are going to be Cloudflare and Google Cloud. And so those two have both primarily adopted JavaScript and TypeScript as their primary programming languages. This could limit some adoption just because, if a lot of the backend developers and users who are doing more of the event processing systems aren't maybe as familiar with writing JavaScript and TypeScript platforms, but because of the ubiquity of the front-end technologies that are built on JavaScript and TypeScript, there should be plenty of people out there available to work on those platforms. And then IBM is the last company that I want to talk about here, and they're actually taking a little bit of a different approach to their cloud and serverless strategy. So because they've come into the game a little bit later than most of these other companies that are on the list here, one of the things that they've done is they've decided to embrace Knative and container runtimes as their platform. And so this really allows users to continue to build out everything like they're doing today if they're running in Kubernetes, but then or whatever they're using for their containerization, but then to jump in and use the Knative for helping them to scale their systems. So, because this is the Azure user group, we obviously want to focus in more on what does Azure offer for serverless. So about a year and a half ago, Springtails made the decision really to commit to Azure being our platform of choice. And so I've been able to have a chance to really dive into a lot of these technologies and understand what they provide and what some of the benefits and disadvantages of them are. So Azure Functions is the one that everybody's heard about, but you might be surprised at what else is offered today from Azure. And so that includes Serverless Kubernetes, app environments, serverless SQL Server, Logic Apps, Event Grid, and Blob Storage. So we're going to jump in and talk a little bit more about each of these platforms. So Azure Functions are the first one we'll talk about. And so all Azure Functions are set up to have some sort of an event trigger that takes the code and causes it to process. So whether that's an event like an HTTP request that's part of a webhook, a file being created in blob storage, or a message showing up in the message queue, or a timer elapsing. Azure allows you to write your function in a variety of programming languages, and you have the options of either running precompiled binaries that you've built, like if you're using .NET or Java, or if you are wanting to do more of interpreted code with TypeScript or Python. They even have C# scripting that is available as well. So, and those ones that are interpreted, you can actually edit that code through the Azure portal. And really, the whole intention of the functions is they take some type of an input and produce an output. By default, Azure Functions are set up to have a maximum processing time of about 30 seconds. If you go into more of like the premium level of them as opposed to the consumption-based level, then you can have functions where you can configure them to run for longer periods of time. But the whole point of the code is that it is short run and it is stateless. And so one of the things that they've added more recently is the availability to create composable functions, or what they call durable functions. For those of you that are familiar with AWS, it would be the same as the step functions or step or lambdas that AWS has. So with these durable functions, you're able to compose a flow of events where a stateful orchestrator will make calls to the entity functions to save or update the state of each individual piece. And there's a wide variety of use cases for what you can do in these durable functions, including function chaining, which means taking the input of one function and then passing that along to another one. Fan out and fan in, which means taking a single event that comes in and sending it out across multiple different processors. You can also do asynchronous HTTP calls, human interactions, or doing an aggregation of state. And Up next, here's a screenshot, and I can maybe blow this up a little bit so we can see a little bit closer what a standard Azure function that written in C# kind of looks like. So you'll see here that with that function, it has a trigger that is defined on it, and it does a little bit of work, and then it sends back a response. And each Azure function has to have a unique name to it, so that when that function is being executed, it knows which code to link up to. Up next, I'm going to talk about the serverless Kubernetes. And so there are two primary routes to go within the serverless Kubernetes. The first one is using Azure container instances. And so that really means that we're going to continue to use our containers just like we do today, just that we let Azure figure out how to pull down those images and run them with a little bit of orchestration, as opposed to relying upon having to specify Helm charts and all of that kind of stuff to manage the Kubernetes environment. And then the other part that we can do with serverless Kubernetes is using the Kata scaling. And so what Kata is it's actually a technology that is been adopted by the Cloud Native Computing Foundation. And the Kata allows you to define rules as to how services within a Kubernetes cluster are run and how they're scaled. And so within Azure, when you're running your Kubernetes cluster, you can use virtual nodes to not have to pre-allocate all of the resources that you're going to need. So with Kata, there's a good number of different triggers or values that metrics that you can use to figure out whether to scale up or scale down your Azure functions. And through this process, then you can obviously be able to scale all the way down to 0 resources running. And up next is our Azure App Environments. And so within the Azure App Environments, we have the Azure App Service, which Microsoft will tell you is a serverless platform, but in my opinion, it's really closer to running a virtual server because you have to pre-allocate the resources that you're running. You just don't have to manage the operating system and everything that is below it. You just upload your zip file that has all of your app code in it, and they will go ahead and run that for you. And then one of the newer technologies that Microsoft has been working on is the Azure App Containers. And so the Azure App Containers is kind of a little bit more of a mixture between Azure App Service and Kubernetes. So what this will allow you to do is, it's in beta right now, but it will allow you to use the Kata scaling rules like you can do in Kubernetes to figure out how to scale the individual apps within your container app, but you don't have to handle all of the orchestration. You don't have to learn how to do all of the Helm charts and everything like that. The other thing that the Azure Container Apps do is you are able to deploy all of your services together within that grouped environment. And in that grouped environment, then the services can easily talk to each other using the Dapper runtime for service discovery. And like I said, it allows us to build out scaling rules that Kata uses. And in my testing with the Azure App Containers, there's still a bit of functionality that's missing. They don't have support for your private networks or anything like that. So I've also run into a few issues with being able to have the containers running in that Azure Container App Service, being able to read app configuration and talk to other services outside of the container. So hopefully once Microsoft gets those things squared away, it'll be a great platform that will kind of offer a nice hybrid between all of the other platforms that are available today. And lastly, I'm going to kind of talk about the other services that Microsoft is offering in Azure. So coming into this presentation, I was pretty skeptical of logic apps, but having tested them out a bit, I can see how they can be pretty beneficial for a company to use them, especially maybe in the near term. They allow you to build a low code or no code platform. Allows you to do the orchestration between all the data between systems, and you get to build out and connect all of those data sources and services. And if there is not already a connector out there for the system where you need to retrieve data from or push data to, you can build your own custom connectors. Microsoft is really leaning into this, wanting to allow business analysts to be able to piece data together from a variety of different systems. And so what that will allow you to do is have your engineers be able to work on things like the Azure Functions, and then through the Logic app, then orchestrate the communication between those. A good example of this would be, building out some sort of like a business rule for it on the Springtails side of things, building out business rules as to whether an item can be listed on a marketplace or not if it has all the required data. And so it would allow us to do that on the business side of things, where they can set all the different rules. They could also set up data transformations and things like that, and then use the Azure Functions to then publish that data to the marketplace. Event Grid is a system I'm excited about using, and being able to use that to have events published. There are a couple of different events formats that you can use to publish events. And some people ask, what's the difference between, like, why would I want to use Event Grid versus Service Bus versus Event Hub? And Event Hub is, really primarily targeted towards using IoT type processing, and the Service Bus is really meant more for the synchronous communication of large messages, whereas Event Grid is really meant for just sending out small notifications of messages or notifications of changes or events within your systems. And then it will, within Event Grid, you can do both domains and topics within domains. And then when you're building out the subscriptions to a topic, you get to add in additional filtering. So only certain types of messages with certain values will be delivered to your particular subscribers. And then lastly is blob storage. And, I could understand if people would be skeptical or, concerned about, well, how can you say that blob storage is serverless? And the reason I say that it can be considered as serverless is because any static web content that you have, instead of having to publish that to a web server, if you publish that to blob storage, then you can hook that up to Microsoft CDNs and let them worry about being able to push that content out to all of your users. And so like Alex was saying earlier, Springtails is just starting to expand into the UK, and we just shipped our first order out of the UK, I think, yesterday. And so that means that we're going to have users now that are going to be using our internal tools that are over in the UK. And so if we use the CDN, then we can start to utilize that and let them have that content quicker, as opposed to making them pull data all the way across from the US. So that's one of the reasons I would consider blob storage to be another serverless technology. So up next here, I've got a picture of kind of what one of Springtails systems looked like that I worked on when I started about 3 years ago. And so the first thing that we have coming in is item, price, or inventory events that go into a RabbitMQ. And so then with those events, we had a monolithic executable service running, Windows service that was running that had different message handlers built into it. And so when those messages would come in, we would take and save the data to a Redis cache. And then at the same time, we would also keep a list of items in a separate Redis cache that had been updated. And then we had 3 different timers that were sitting out there and firing. And then each of those timers would go read all of the data that was in that set of batch items, and then take that data and communicate it to the Google Express APIs, and then clear out the items that were in that list of batched. And then when the next update came through, then it would go into that batch items again. This was problematic because when we had things where we didn't have any sort of concurrency locks on those batch items in Redis, we could end up having updates that got missed because of, weird timings and things like that. So we have slowly evolved our architecture, and so this is kind of what the system looks like today. So we still have all of those messages, events firing through RabbitMQ, but instead we actually have a system that is taking those events and saving them into a Postgres database. And then separate from that, we have, and there's an extra arrow in here that shouldn't have been in here, but we have cron jobs that we've built out in Kubernetes, and these cron jobs are going in and they're talking to gRPC services to do an orchestration of events or workflows to go and retrieve data from that Postgres database, do all the manipulation that it needs to, and then sends that data through a data access layer over to the Google Express APIs. And so this has increased our stability quite a bit. And as we've built out these separate gRPC services, that's really kind of paved the way for us to being able to transition these things more into serverless, because those different jobs that run today, because they run on a schedule, means that we still have those orchestration data access services sitting and running idle for most of the time. So here's a picture of what I could see a future vision for our system looking like, and something that we're slowly but surely transitioning to. And so you still see that we've got RabbitMQ on, generating your events and getting pushed into the first half of the pipeline. But then the second half of the pipeline, we could start utilizing things like Azure Functions and Logic Apps, and probably even event grid messaging and storing off the data that we're pushing through blob storage to handle all of this as a fully event-driven serverless system. So now I'm going to jump over and do a couple of demos. So the first demo I'm going to do is going to be showing you a couple of different Azure functions. After that, I will show you an Azure Logic app, and finally some Azure Event Grid setup. So I'm going to switch screens that I'm sharing here, and I'm going to share my, first off, I'm going to share just some VS Code so we can see what it looks like. So, this is similar to the screenshot I showed earlier. So this is just a basic demo for an HTTP trigger. And you can see here, we're just reading in request body data, and then depending on whether data was filled out or not, then putting out a particular result message and returning that result. Another type of Azure function trigger is going to be using a queue trigger. And so these queue triggers are going to be using the Azure storage queues. And so This one here is pretty basic, but anytime a message gets dropped into the queue, this is going to spin up and it will log out a simple message. Nothing too exciting going on there, but just to show a different type of trigger. And then the third one we have here is actually a little bit more complicated. So what we're going to end up seeing here in this example, this code example, is we've got an HTTP trigger for the incoming request, but then we also have a separate binding here for event grid. And so what this binding for this event grid is going to allow us to do is we can actually then take that event collector and publish events to that. And so there are multiple different bindings that are available for both input and output on the Azure Functions. And yeah, so, and then the last one I have is this is going to be just an Azure function that is run when there is an event grid item that triggers that event. So that'll be the last demo that I show, but I am going to show what this all looks like in the Azure portal now. So I get the right window. Yes, this one here. So this then, before the meeting today, I went ahead and actually published all of those Azure functions out here. So you can see the demo trigger, the MyQueue trigger, the event grid, and then the OpenAPI HTTP trigger. So the first one we're going to do is we're going to come in here and just through the Azure portal, we'll go ahead and execute. So we'll do a run on this function and we'll run it a couple of times just so we can see the results. So I think this one is needing a parameter. And let's go ahead and run that again now. Yep. Hello, Matt. This HTTP trigger function executed successfully. So if we remember that code that I showed earlier, the very first demo trigger, this is what we would expect because we had a name input. And so, you know, and we can come in here and show Omaha Azure. And we'll go ahead and run that. And we see that we still get the same result. And as we're looking at it, we can see, you know, it's showing us logging here of what's happening on the server side of things with the execution of that trigger. And here is the log of that C# HTTP trigger function processed a request. So a little bit of a different one, if we actually, yeah, we'll look at the OpenAPI HTTP trigger. So this was the one that is set up to publish an event over to the event grid for us. So I'm going to go ahead and run this again. So name and event grid, and we'll go ahead and run that. And said hello event grid. We didn't see the message here in the logs just because the logs connected after we executed it that first time. But I can actually go ahead and if we look over here, I might have to refresh this. The one thing I have found is some of the time these don't update quite as quickly as you'd like to see them with the metrics to see when the events have triggered. But the other thing that I've done is I've set up with the App Insights. And so within the App Insights, if I go ahead and run this through here again, we should see that we have executed a couple of different triggers and everything like that. And one of those should have been the event grid getting triggered. I'm not seeing that for sure, but those would be the first two types of Azure functions that we had. And so now I'm going to switch to another window here and show what it is like to do a message into just adding a new message. And you guys are probably not seeing this new pop-up that came up, but I'm going to just type in a demo message here and go ahead and publish that. And so we can see here's that message that I just published. And so because we've got another Azure function that's triggered based off of anything that's happening in that queue, it should, if I refresh this, message should be popping out of that queue, and there it is. So, it took us a little bit of time to get that message to process out of the queue, but not too bad. So that's where I'm going to leave the demos with the Azure functions, and I'm going to actually show a logic app that I built out that is going to use a little bit more of it'll actually tie together a couple of these Azure functions that I've built. So if I come over and look at, so I've just created a very basic logic app. And so then within the logic app, what we have is it allows us to come in here and work with a designer to start building out what we want to piece together for a workflow. So you can see here, my very first event that I have in my workflow is when an HTTP request is received. I'm not doing anything special with this request, but we've used logic apps to, say when a certain webhook comes in, then parse it and pass it on to an Azure function. So you can see then my next request here, or next step in my logic app, is to make a call to my demo HTTP trigger in my Azure functions that we built out earlier. And then step number 3 in the logic app is to go ahead and create a blob file in the blob storage. And you can see here there's a couple of interesting little things that get passed in here. And so this is where we actually can use dynamic content. And so when I'm creating this blob, it's going to create a new blob name that's using the current UTC time and a .text extension on that file name. And then the content of it is actually the body result that came from that demo HTTP trigger. And so then the last thing that it ends up doing is it will publish an event over to our event grid, and the event that it's going to publish is going to pass along information as far as what file got created and when it was modified. So because of how logic apps are built, they're actually they have a code base behind them that's all JSON. So, in theory, you could take and you can version this information and be able to, publish as you make changes to the designer, save this off to your code base and be able to, keep track of what the different versions were. So I'm going to go ahead and run this trigger. And as I run it, it'll say it's performing the action, and then in just a couple of seconds here, it will refresh, and we'll see that we have green check marks across the board. So it means that all of these requests executed, and it also tells me how long each of those requests took to execute. So this whole process, the longest thing here was creating that file in the blob storage. And if I expand it here, it'll actually show us a little bit of the outputs. And so we can see that, this is telling me that the file that it created was named 202205, so the date time stamp, and it was 135 bytes, and it was just a plain text file. And then when it published that event, you can see here that it pushed over all the information that we're expecting it to. So again, this is the actual event that it published over to the event hub, or I'm sorry, event grid. So if we come back and refresh this now, we should hopefully be seeing some events updating here. Let me cause more of a refresh. So here we can see from earlier, these were our events that I published, and then that was when that Azure function processed that event. And then here's the most recent event that was triggered by the event grid when we did the logic app. And very shortly, we would expect that we would see some logs in there showing that Azure function, again, processed that message coming in through that topic. And so I will go ahead and hopefully we can get back here into our Azure App Insights, and we should be able to see actually some of the logs. So here you can see where there's where it executed that event grid demo function, and the data that it logged out there that it processed was that file name. So we can kind of prove there that everything that, you know, that orchestration of that workflow was complete. And if I switch back over to our Azure Storage Explorer window, I will show, no, not that window, this window here. If we come in here and look in this demo folder and refresh, I now have this file that was published, and it's, oh, yeah. And so there we have that file that it was pulled down and created. So, and with that, I am going to, let's see here. Let me share again. We are ready for questions if anybody has any questions.
I don't see anything on the chat, but yes, if anyone has any questions or comment, feel free to unmute yourself and you can ask now. Please go ahead. I guess everyone understood everything that you told today.
I must have done a perfect job.
Hey, Matt. This is Sunil.
Hey, Sunil.
Yeah, my question to you is, which one of these serverless functionalities or offerings are you most excited about, and you would see them, being adopted in Springtails?
Yeah, I really think utilizing the more of the Azure functions, just with having the availability to have both the input and the output bindings, that's the part of it that I'm most excited about. I know some people are trying to run Azure functions like within Kubernetes, but I don't think they really have the availability to do quite all of those different types of input and output bindings that the standard Azure functions give us. And so, being able to do some things where we tie those into incoming messages from an event grid, and then, being able to publish events and things, different events through event grid after, that function has maybe done some additional processing and saved off some data. I think those are really going to be, from my perspective, the biggest places where, we can really jump in and start utilizing more of this technology.
Exciting times. Thank you, Matt. Great presentation.
Oh, thank you. All righty. Well, I don't see anybody having any questions, so I appreciate everyone's time.
Thank you so much, Matt, for taking out time tonight. Excellent presentation.
Thank you.